Hey, hey, welcome to Algebra 2. I'm Ms. Thompson. There are a lot of foundational pieces to be able to do in this class. Congratulations, you've made it to a level of math where now you are going to be thinking about all the things that you've learned on a deeper level, on a higher level, okay? Think of it this way if you like a book, right? You're not talking about the plot of the book anymore, right, in English class? You're now talking about, like, what it means, right? And much like your English teacher probably has more ideas about what it means than you do, that's not, the point isn't to be perfect. The point is to push your brain into a different place, okay? So I am going to try my best to re-explain in these first couple lessons pretty simple topics. I don't mean simple like they're easy, I just mean they're foundational level topics, in the hopes that they come off as review, that they help fire your brain a little bit from a long summer off of math class, and that they help you to maybe understand certain aspects of mathematics in ways that maybe you didn't before, that'll make then higher order thinking easier, okay? So the first thing toward that goal is numbers. Where to begin? There are whole branches of mathematics called number theory, and there's all sorts of things about what is a number and what's the purpose of numbers. We use, right, now, I could write numbers like this. Did I write the same numbers, or did I write different numbers, right? You could say this is 1, 2, 3, 4, 12, 34. What if I wrote this? We'd say that's 1,234, wouldn't we? What if I wrote this? What does that mean? Well, we usually say 12.34. Well, what does that mean? You go, oh, if you don't know, how can I know? I do know. If I wrote this, how about this? Yeah, you're welcome. Wouldn't it be nice to do calculations in this? How about this? Shoot, what are those? I can't quite remember. Let me get back to you for my Babylonian symbols. I don't want to remember what they all look like. It was like this and that and that. It's things like that. Okay, the numeration we use is called something. It's not because there aren't other options. There are other options. They just don't work well with computational math, okay? This is Babylonian, I believe. I forget, I'll figure it out. I'm gonna do a video on that. This, maybe you recognize, are Roman numerals. And when you wanna get fancy on a clock, or like on certain things, use Roman numerals. Interestingly enough, copyrights still, like in the logbooks, go in as Roman numerals, because, I don't know, everybody still like wishes we were Roman. These are called Arabic numerals. We use Arabic numeration, okay? We use a base 10 system, okay? Babylonian is base 60. There are things that are base 20, Mayans. I really need to fire those glyphs. This is base 10. Again, it's our Roman overlords. We're hearkening back. So, I'm going to erase these. So, we know things about numbers, right? I'm going to write this. Okay, what if I write this, or this, or this? Are those different, or are they the same? This we would probably call a Do you remember what it's called? It's a whole number, right? It's also a natural number. It's an integer. It can be written as everything. It's real. These are all real numbers. We're going to talk about number systems in a second. This would be in decimal form. Is this the same as this? Yeah, it is. 12 over 4 is 3. I'm going to show you. We all know this. You see my 3 circles? Oh yeah, you can. So, we've got pi, not the number pi, like actual pi. Let's say I have 1, 2, 3 pies divided 4 ways, each of them. How many slices do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12. Huh. 12 and 4, 3. They're related, right? There's a reason for this. So let's talk about numbers. I'm going to erase this. If you need me to not erase it, pause it right now. Okay, now I'm going to erase. So we're going to start with the lowest level, natural numbers. And they get a fancy symbol. Ready for it? N with a double bar. So natural numbers are counting numbers. I just did it, right? You can still see the remnants here. Count, right? 1 pen, 2 pens, 3 pens, 3 pens. I can count things that don't have the same things. 1 object, 2 objects, 3 objects, 4 objects, 5 objects, 6 objects. You can do lots of different things. That's why it's very important to decide what you're counting, okay? I don't know that my keys and one of these caps have anything to do with each other except for they're both on my person, so I guess that's their relationship. Okay, those are natural numbers, things that you count. You don't count the void. I don't have any movies playing for me right now. Why did you say that? There are no llamas in this room. Of course there are no llamas in this room. Well, there might be. We might get goats. Miranda. Anyway, so when you start talking then about zeros, so natural numbers are counting numbers. 1, 2, 3, 4, and so on forever. Okay, the ellipses, the dot 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 means infinitum, infinity. Whole numbers, which are wholly overused as a descriptor, they're just natural numbers with 0. That's all it means. We added that in. 0. Okay. There's a math guru out there who can tell me what the fancy symbol is for whole numbers, because I really don't remember and I can never seem to find it. Because they're that unimportant. Colloquially though, however, we use that phrase all the time. Shouldn't. Okay. Next, big one. Usually when you say whole numbers, you mean this. You ready? Integers. We get a fancy Z. This comes, I think it's an Arabic word. I need to look it up again. I've known it before and I forget. I don't know if you're aware of this, but as you get older, you actually forget almost as much as you remembered. It's a blessing and a curse. Integers are all these with the negatives, right? This is where negative numbers come in, but they're all, so I'm going to do the ellipses. We came from infinity. -3, -2, -1, 0, 1, 2, 3. Well, they're integers. Next big body. Rational. fractions and most decimals, but for purposes of definition, I'm only going to say fractions, okay? Positive and negative fractions. Okay? Things that can be written as a ratio. Now, there's a very famous story I'll tell you about the square root of 2, because it proved that this is as far as like the Pythagoreans went. Okay? Everything is number. And everything can be written as a ratio. This was like religious stuff here. Okay? And then this poor guy, I'm not going to give you the proof now. I'm sure you can look at it. I know it's a TED Ed proof. It's kind of cool. Realized that the square root of 2 is not rational. That is, it cannot be written as a fraction. Square root of 2 is about 1.41 blah blah blah. Okay? So square root of 2, here's another number that's not rational that you may have heard of before. Seen this before? Can we see this down there? I gotta change this. You gotta be able to see it. Hold on. There it is. Let's zoom too. Let's zoom it in, yo. Instead of saying not rational, we use this word. Irrational. Irrational. Not rational is apparently too easy. Okay, gotta zoom out again. Looking at the big picture, like literally and figuratively and metaphorically and all of it. Okay, so here we are. Hold the phone.